Alright guys, I'm writing down prices of motors and writing them down by size for brushless, sensorless motors on eBay. And I'm going through everything with a fine-tooth comb, taking notes, comparing. A lot of them are missing certain stats, so I'm kind of like filling in the stats with similar sized motors and making little comparisons and just feeling things out, trying to make sense of it all. These are going to be Adams motors. I'm not going to use DC motors. Well, they're called DC motors or brushed motors. Brushless motors generally aren't referred to as DC motors, even though they're both DC motors. These they just call brushless motors. But both brushed and brushless motors are DC motors. They're just traditionally not called DC motors when it comes to brushless motors for whatever reason. So brushless motors are more efficient, substantially stronger, use less battery life, less friction because they don't have brushes, lower maintenance, cleaner running, don't shoot off sparks. Oftentimes they're even waterproof. They are more powerful in size to weight ratio. They use neodymium magnets inside rather than windings and brushes. They're lighter weight for the power, so that's going to cut down weight a lot. Less maintenance. They're just better in so many categories it can't be ignored. Now, I'm still going to use brushed DC motors, which are about 4 times cheaper, but not in Atom. Maybe for like little tiny stuff like the eyebrows or something, but the big honking motors being used for the heavy lifting, the thighs, the biceps, the back, I mean everything, the shoulders, those need to be brushless. And I am stopping before I make a big mistake. By trying to be cheap, I'm gonna end up having to replace everything otherwise. I'm stopping my DC brushed motors obsession because of the low price to just look at reality, which is that these motors have taken over the electric scooter market. Brushless motors have taken over the electric skateboard market, hoverboard market, electric bike market, one-wheeled motor market, Segway market. Brushless motors are used in all cars, even though those use induction motors, they are brushless. Um, Brushed motors really are becoming replaced by brushless, and everyone runs to brushless if they want to upgrade. Also, the RC car market's all upgrading to brushless. Brushless has taken over, and I need to get with the times because I don't want my robot to have inferior quality parts and then be overweighted and less powerful and stuff and more maintenance. I'm not going to do it. How many will I need? Like hundreds over the years. I mean, I'm building a robot army, but maybe I'll start off buying like maybe $500 or $600 worth. Eventually, I'll need like $2,000 worth, most likely, just for one robot. It's really a expense I can't avoid, though. It'll be worth it in the end, though. The robot's gonna be super strong. Probably we were worried about the robot not being strong enough, right? I told you guys it'd be a man-sized robot with the strength of a child. But if I use this type of motors, it's actually going to probably be as strong as me, or at least getting closer, a lot closer. And so that's nice. I'd love to have a robot that's like nearly as strong as a grown man. That's excellent. And these motors make that possible. Look at this. This is a small motor. Look at the thick wires. That means it's getting a lot of juice going into it because of those thick wires. You don't see that with like DC brushed motors. These things can handle tremendous wattage. I'm gonna start off buying like a variety. So I'll buy like some big boy like cordless drill sized motors, which are pretty much all of these. They range everywhere from $30 to $60. I'm seeing, and then some of these smaller ones, they're still fairly beefy, are in like the $20 range. Well, 15 to 20, and then the real small ones start getting into like the $10 range, I guess, or even as low as $8. But I don't know if the $8 ones are any good. I'm not sure. I love when they've got specs like this. This is great. Okay, 3100 kV. $900. That's excellent. Really, really good. My electric bike is 1,000 watts and it's a beast, and this is just a little tiny motor. It's only 50 millimeters long, which is like 2 inches long. It's just a little tiny thing cranking out 900 watts. I mean, this thing's going to be a beast. $56 amps max current. You can't make Atom all that strong because motors just aren't strong enough to make them as strong as human muscles for the same size. Human muscles have more strength for their size than any type of motor or any other type of actuator. The only way you can make it stronger than a human is if you made it a hydraulic robot, which requires an external hydraulic system. And there's a lot of problems with hydraulics. Actually, no, even with hydraulics, all the controls and stuff would make it way too big too. It wouldn't fit in a human body. Hydraulics are not good at saving space. Most efficient use of space is brushless DC motors. By the way, I still have all these brushed motors. Now I'm buying brushless. The ones I already bought, I'm still going to use for other projects, like the CNC machine and maybe certain home automation projects, maybe some commercial products, maybe certain types of prototypes for different things. But for Atom, my number one most important project, my claim to fame, the thing that I want to be the best robot in the whole world, I'm going all out for Atom, and I'm buying the best motors. That's going to dictate his success very much so. I'm not going to stunt myself by buying motors that aren't the best bang for their size, so I can maximize his strength to weight ratio. That's very important. And this is a serious motor right here. This is what we're talking about. Serious motor right here. 50,000 RPM, high torque, 4-pole, 2200 kV, brushless motor, for 1/8 RC truck, so 1/8 scale. This bad boy is sporting some crazy specs. 2800 watt peak. James Bruton's is 2200 watt peak for the motors he used on his, which were the 44 volt Turnigi 2400 watt peak motors. Okay, so no, never mind. His is 2400, this is 2200 watt. So they're very similar in wattage. His 149 kV, this one is 2200 kV. James Bruton's has $83 plus shipping, so like $92. This one's $43. Free shipping. His is 44 volts. Mine is 36 volts. You could probably run mine off 44 volts if you wanted. It's not that much of a difference in voltage. Oh, wait a minute. Am I looking at the wrong one? Oh, I am. Okay, what's the voltage on this? Doesn't say. What the heck? Weird. Really weird. It's probably 36 volts again. Even though it didn't say it. So that's something I'm probably highly likely to buy. How much will Adam be able to squat? I don't know. I really don't know. Well, I would say maybe 120 pound squat. Maybe 150. One's a piece of crap. It looks cool though. $51.35 kV. Here's where it falls apart. 56 amps max. .4 volts max. 410 watts max. I'm glad they gave those specs, but we've got stuff all around it the same size that's stronger. This one right below it is $5 cheaper and puts out almost double the amps and a third more watts. But then there's one $10 cheaper here. Here's another one that I don't know. There's some crazy better ones down in here. These 3660 brushless motors are way better. I love the specs, that was nice. Oh, that's another thing, yes. Brushless motors, the ones with neodymium magnets and no brushes, are much quieter. So these are going to run real nice and quiet. It's going to be nice. Let's see. .4074 is the motor size. What was the cost? It's a tourniquet. It's probably way too much, but we're just $56.49. We're just trying to get a feel for the competition. Okay. The KV is 1400. Okay. Max voltage 29 volts, 7S. Okay, that's good to know. Case length 74 millimeter. .40 millimeter in diameter. 91 minus 74, 84, 94, 93, 92, 91. 17 millimeter shaft. Wow, that is cheap. $32.36. 330 kV. I gotta show this one. It's a hot seller. 330 kV. Um, 2,500 watts. Insanely powerful. I mean, my e-bike is 1,000 watts. .1 to 36 volts. .50 millimeter diameter. Okay, that's kind of small. Motor length 79 millimeter. .20 millimeter shaft. And it's censored. That's what those little wires are for. Oh my gosh. It's even got Hall effect sensors. What the heck? Oh, 59 millimeters long. .50 millimeters wide. Well, this shouldn't even be where it is then. It's not that size. 59 by 50, where would that even go? 59 long. By 50 wide. Guess like right here? Yeah, it's between these two. Huh. And it's motor length of 79 millimeters. But that's going to be 59 after you take off the shaft. Yeah, it's the same size as that other one. But it's even cheaper at only $29.33. Look at that. $29.33. Even has a discount if you buy 3. So I'm pretty much guaranteed to get some of these. What a price, man. Electric skateboard scooters. Okay. Yeah, pretty much electric skateboard scooter motors. That's where I'm at, man. That's what I want to put into Adam, man. I mean, these can't fake it. You stand up on a scooter and you say go for a grown man. I mean, these things have to be strong. There's no ifs, ands, or buts about it. They got to have bearings. They got to be strong, and they got to be a beast. So these are some serious motors right here. Serious. And way better than cordless strobe motors. Unless if they're like brushless cordless strobes or something that are very, very expensive. For only 34 bucks and free shipping, like that is the best you're going to get for a robot. You're looking at it, man. Except I found one for 29 though. Same exact motor pretty much. Okay, so let's put this in. It's that 56 or 5065 size. That's the sweet spot, man. Some cheap motors in here that are more powerful than stuff that's in the $55, $85, $100 range, and these are 29 bucks. I mean, that is the best price, and these are powerful, and they're censored with Hall effect sensors, no less. That's a bonus. For the higher torque. Okay, at starting torque. Let's see. 3173. Okay, this one is 330 kV. 36 11.1 to 36 volts. And again, this one's 1800 watts. Okay. 50 millimeter diameter. Yeah, it's all the same as the one above it. okay. It's a little more expensive than the 2500 watt one, but less watts, so that's a red flag. But there's a very good chance that the other one's just lying. You know, marketing. Can't really trust them all the way. But we know it's up there for sure. 1800 or 2500 watts, it's like, just like when I was buying lasers, people were just making stuff up when it comes to that. But yeah, man. We have a lot of good information right here. So, time to start buying. Pretty much got 36 millimeter width, and we got all the way up to 63 millimeter width. It's double the size, so we're gonna want the 36 and the 63. Waterproof, brushless motors, 1/18 scale RC. They're 2430 size. It's a motor size number. A lot of these motors have size numbers, so there's 2430, 3650, 2860, 3660, they're 540, 3650, 3674, 4074. The 540 don't really fit because they're much bigger than what fits in here, and they're just taking the sizing from brushed motors, which are kind of a standard drill sizing. So they're just tossed in here, and they don't fit the numbering mechanism for size for any of the other brushless motors, so they're kind of the one odd exception. They should technically be like called 2900 motors or something. So anyways, these smallest motors, the 2430 ones, are 22 millimeters in diameter, so they're like the size of, they're about the size of a quarter, I guess. And they pack a pretty mean punch though. 200 watts is pretty good, 24 amps. 7.4 volts, so they take higher voltage than these little 5-volt servo motors, which shows that for the same size as those little servos, they really have a lot of power in them. Alright guys, so I'm seeing like you can sort of group them into 3 size groups. Sort of. Well, maybe not. Maybe these should join this lower group. So these range from 36 to 40 millimeters. That's about the same, and then it jumps up to 50 to 63. And all of these are around 2000 watts. The price range going from 29 to 56. Here's 24 actually. Oh, that's that Outrunner used one though. Yeah, we should get rid of that. That's not really relevant. So yeah, the 29 to 56. These are all skateboard, longboard type motors, basically, they're saying. I would say this $29 one is about the best, but the $31, $32 ones are pretty good too. I don't see the point to jump up to $45 to $56 just to get an extra 13 millimeters in width, and it looks like fairly the same output in watts. We're not seeing a big jump up in performance. I'm just not seeing it. 2300 watts is even less watts for the bigger size. So I don't know, that's kind of like odd how that works. As far as these guys, put some stars here. It's something I should buy. As far as this second group, looks like it ranges from 36 millimeter motors, which you can see right here, all the way up to 43 millimeters. And that's the width. And prices go from 1628 all the way up to 56. So obviously the 1628 looks pretty darn attractive right about now. 900 watts right there, but then there's ones that go up to, they claim, way higher than that, all the way up to 2800 watts, 3000 watts. They're a little bit bigger though, that's the 40 millimeter type. Should probably separate that upper group then, because it seems like they're different motors entirely. I don't get it. They're 40 millimeters in width, cranking out the big watt numbers. I could just bump up an extra 10 millimeters, get the same watt numbers, and see the price fall off again back into the $30 range instead of 50 something dollar range. So I don't even see the point. Plus these are Turnigi, they're probably name brands, so these two are going to be very expensive as they're Turnigi. And then this one, I mean 3000 watts, so they got the price marked up, but we can get 2500 watts for 29 bucks. This is 59. It's just doesn't make sense to me. So this whole category I'll pass on. I guess it's like an awkward stage between 1/10 RC and quote unquote electric skateboard longboard ones, which suddenly the price falls off because electric skateboards are blowing up, so they're probably selling a lot of them. They lowered their price, something like that. I don't know. Economies of scale and all that. It's a lot more popular than RC right now, so the price came down. That's where the deal is then. As far as the 40 millimeter size, it's kind of mid-tier, 36 to 40. Looks like we can get this one. It looks like a beast. Most of these are in the 7.4 volt or 11.1 volt. They range from 400 watts, actually 340 watts, all the way up to 1200 watts. This one's 1866, claims 1200 watts, 92 amps, 13 volts max, 3600 kV. That looks like the winner, 1/10 RC. So this one's the best one. Second kind I should buy a 3660 motor for 1866 a pop. It's nice. My second best choice would be the 3660 brushless sensorless motor at 1750 a pop. It's 900 watts, they claim, 69 amps, 13 volts. I like the higher volt ones. I don't want to go with the 7.4 volt or 2S kind. I want to go with the 3S kind, which means 3 lipos or 3 lithium ion batteries in series. I want to have 3 in series as minimum, ideally, because if you can feed it higher voltage, then you need less thick of wires, and it's less resistance in the wire if it's higher voltage. Whereas if you're feeding it lower voltage, it's going to need thicker wires to get the same amount of power through. So higher voltage is better for long range wire power transmission. Okay, next we've got our final category, the miniature kind. That's the 23mm to 36mm category. 50mm long. Looks like it's the same width as some of those in the other category though. And here it's ranging from $9 to $40. It's ranging from 200 watts to 900 watts. $30mm long up to $50mm long. That's a big difference in length. I don't know, maybe the 50mm we should separate because that's a big difference in length. 30mm long is real tiny. So these tiny ones, I would say 925 sounds good. Should probably buy some of those real tiny ones. The 2435 size and 2430 size we're comparing. This one for $498 didn't say a size, and it also didn't have any stats about watts or anything. It just said the size of the motor. It didn't have anything about voltage or anything, so I didn't feel comfortable with that. At least this one had like the kV rating, the amps, the voltage, the watts. That's important to me to have those stats or specs. As far as these, 3650 and 2860 size. It should be moved down. Well, we got 50mm and we got 36mm width and 60mm long. I feel like this size is fine. We can then skip these or group them up. They should probably be in the same group then. Yeah, we'll put these back in the same group. And 1894. Alright, looks like we got our 3 picks. 5065 size for $29.33, 3660 size for $18.66, and 925 for $24.35 size. All those had nice stats, specs written out and everything. So we gotta try to find these now. My tabs. I think I should buy like maybe three skateboard motors for the chest slash back, and then we'd have the delts and lats. So basically X and Y, or up, down, left, right of the shoulder, that's really critical. That needs to be super strong. Just the shoulder. Up, down, left, right. That's 2 motors right there. Bicep, tricep. That's 2 motors right there. Rotation, I'm not too worried about. Grip, not too worried about. Those can be smaller motors. But for the big boys, bicep, tricep, and the shoulder. So, uh, bicep, tricep is 1 motor. The other is 2. So it's going to take 3 of the big honkin' motors, the electric skateboard motors, per arm. So we'll go ahead and get 3 of those. And we'll go from there. Alright, $28.16 each, because I bought a pack of 3 of them. $90.36. Bought it. Ouch. But not ouch. I mean, this is super worth it. Oh my gosh, is it worth it? That's the cost of one of James Berton's motors, one of them, and I just bought 3 for the price of 1. Because he bought name brand. And these are as strong as his, very close to. Okay, so that's my arm. That's 1 arm. That controls the shoulder and the bicep of that left arm. Yep, lats, traps, rear delts, and pecs. And front delts go with pecs, kind of. That's the same group. Trap and top delts are the same thing. Same motor, pretty much. Well, not entirely. Not entirely. Alright. So I just want to get a start, you know. 3 should be good. And, we'll end up buying a ton more, obviously, later on. But this is a nice way to fill out the market without spending all the money right away. We just get enough for our arm. That's what we're building for now. Now these 3660 size motors, these we're going to need quite a fair chunk of. These are going to handle a lot of stuff. We should probably buy like 20 of them. They are 60 millimeters long. And 36 wide. Yeah, we need like 20 of these. At 20 bucks each, that's going to cost me 400 bucks. Ouch! These are the 1/10 RC scale type. Ouch. 3660 brushless for 1866. We got to try to find that. Let me save this order in my receipts, business expenses. Alright boys, I just bought 7 2430 motors at like $10 a pop. That adds to my 4 I already bought. So that's 11 of them I bought. And those are the smallest of the small, pretty much. But these are 200 watt motors, super powerful for their size, unbelievable. And we could use that for the thumbs and a bunch for like wrist, kind of forearm stuff. Stack them up for forearm strength. And thumbs, let's see, individual fingers and stuff, maybe aiding in that. Maybe we can use some really small ones for the fingers as well. For like doing this, we could use really, really small ones. We could just use non-brushed ones for that, but we'll want the brushless for like anything that needs to be like really strong movements, fast and powerful. Anything we want a lot of muscle to it, we'll definitely use the brushless. Okay, let me get the stats off this. I write in the notes what I bought, the stats on it, everything, when I purchase things. Okay, 24 amps, 200 watts. Okay. And the voltage, 7.4 volts. $380 is our total now for Adam's one arm. That's an expensive arm. What the heck? But you're gonna see results now, as far as obviously when we get around to it. But you're gonna see a powerful arm. This is gonna make a huge difference. So it's like 800 per leg, 500 per arm. 2,600 for legs and arms. Plus you got like back, torso, abs, all that stuff. So, I mean, it's probably going to be like $3,000 worth of motors now. Whereas it would have been like a 1,000 or 900 if I went with brushed DC, which is what I bought originally. But I'm going to pay more to have the robot twice as strong, lower maintenance, less work long term, more efficient, quieter running, no sparks, cleaner running, more efficient, better battery life, up to 40% better battery life on a brushless motor versus brushed. You can fit more motors in, because they can be smaller for the amount of power they have. So it's just going to make the robot way stronger, faster, better in every way. There's just no comparison. So, yeah, it's more expensive, but as many years as I'm putting into Atom, it doesn't make sense to go with crappy motors when I can get the proper latest technology stuff. I really have to do that. You can't skip out on strength and speed and stuff like that. Obviously, I can skip out on that for certain other projects, but Adam's such an important part of my life that he really deserves the best. He's my child. My children deserve the best. So, yeah, I guess we're done for now. I kind of know what to buy in the future. And I took notes on all that. We'll make a video about it. We'll be good to go. I finished that though on my to-do list. I bought the motors, and that combined with some of the really tiny stuff I already bought, I'll just go with my brushed still. But the brushless for anything substantial, it needs to be really strong. And we'll go ahead and buy more motors once we get to further steps. Like if we actually have the next arm finished, we can buy motors then. But you guys know that's going to take years, because just building the left arm skeletal structure, we're almost done with that now. We just got one more bone being printed over the next couple days. It's going to be shipped from another country to here from my freelancer who's doing my 3D printing. This bone, like I said, needs to be scaled up a little bit, so I'm going to cut it where that black line is and extend it and add in material to make it a little bigger. And once I have those 2 bones, that will be the shoulder girdle done. We can mount the finished arm to the bucket with the shoulder girdle, sew it all together, strap it all in tight. The arm will be semi-permanently on the bucket, and then from there we'll be ready to put on motors, create our battery pack, create our control systems, create our power supply. All of which we've been working on in general already, but I consider those separate projects. But as far as finishing the structural engineering of the robot, will be finished at that point. Plus mounting the lamp stand. Then it's just a matter of doing all the electronics work to make it all capable of moving, and then doing all the software work to actually give it intelligent movement and feedback systems and all that fancy stuff, the AI or whatever. And that will take us years, so during those years we'll be able to recover the money we spent on all the materials to make the structures and all the materials to make the electronics stuff come to life. And we'll be able to save up money, and eventually for like the other arm and the legs and the rest of the body, I'm sure we'll get plenty of money saved by then. But who knows, maybe if I have a finished arm it's actually building the rest of its own body and people are really impressed with it, I'll be able to get some patrons and donators for the project to buy the rest of the stuff for me. Not that it really matters, I don't need that, but in general, if people are hyped about me building the robot again, then they're going to want to contribute funds just to help me out to keep going. So I do anticipate that.